Okay, so we are going to start. This is the last page of 10.1 notes. So the notes that we covered last time, this page and this page, and then go to this third page, and here we are. It says here, we learned in Unit 9 that we can factor a polynomial to find the zeros. Okay, do you guys remember Unit 9? You would go through, you would factor a polynomial for what purpose? So we could find the zeros, and then from those zeros we could graph. We would do in behavior, bounces and crosses, and we would go and graph the polynomial. So the first step, if I want to find the zeros, that's what we're leading up to in this unit. The first step is to factor. It has 4 terms. Do you remember how to factor something with 4 terms? Group it. You group it. So my first step is I split it right down the middle, right? Okay, split it right down the middle. And let's see if you can do it on your own. Let's see what you guys remember. Let's take a look. Factor by grouping. What's the GCF on this side? X squared. What about over here? What's the GCF? Negative 1. Remember, if that's negative, you always want to take that negative out. So the GCF is negative 1. Okay, so I take out the x squared. What's left? X plus 5. I take out the negative 1. What's left? Nice. 17x plus 21. Okay, the next step is what? It's when I take out this part that should always match. Do they match? No. And in fact, last term, I taught my students, I said, hey, they better match or else what? You did something wrong. You better go back and find what you did wrong and fix it. But guess what? You didn't do anything wrong this time. Okay? Up until now, we have given you very specific problems with 4 terms that could be factored by grouping. They were special. Not every polynomial with 4 terms, which we call a cubic, because it starts with x cubed. This is a cubic polynomial. Not all of them can be factored by grouping. They can be factored, just not by grouping. So guess what? The entire Unit 10, this is our sole purpose. How to factor cubics that can't be factored by grouping. And guess what? You're also going to find out how to factor quartics. Guess what quartics are? They start with x to the 4th, okay? You're going to learn how to factor them without starting out factor by grouping. Now we're going to get to it, but not everything at once. It's through the whole unit that helps us, okay? But to start out, what if I took that same polynomial and I give you somewhere to start? Slide down here. Would it be helpful to you, and slide way down here, if I told you x plus 1 is a factor? Would that help you or not? The answer is yes, but you may not realize it yet. Okay, you know how I like to use basic numbers? Okay, follow with me. Are you ready? What if I told you I want you to factor the number 2,907? I said, go factor that number. Well, you could pull out a calculator, right? And you can start typing in numbers and see if you can find something that divides into 2,907. But what if I gave you some place to start? What if I told you 17 is a factor? We always do factor trees, right? Okay, you have a calculator, grab one. Quick, 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 quick. Grab a calculator. If I told you 17 is a factor of 2,907, then what would you do next? What would be your first step in finding the rest of the factors? You would divide, right? In order to find the number that goes right here, you would take 2,907 and you would divide it by 17. What is that number? 171. Okay? We're going to use the same concept. Even though it's messy polynomial, it's still the same concept, you guys. Okay? If I have a big number or big polynomial, and I give you one of the factors, where do we start? We divide these two to find the other, right? Okay, we're going to do the same thing right here. Here's my polynomial. Here's where I start. I give you one of the factors. So what I'm really asking is take x cubed plus 5x squared minus 17x minus 21 and factor this. Okay? I want you to factor it. But I already gave you one of them. What did I give you? I gave you x plus 1 as one of the factors. So how do I find the other? How do I find the rest? We're going to do what?
Divide it.
We're going to divide it. Do you know how to divide polynomials?
Yes.
Yes, you do, because I taught you last time. So come over here to the side, and we are going to divide. We're going to take x plus 1 into x cubed plus 5x squared minus 17x minus 21. Okay, I'm going to give you a minute. You go divide. All right, so how do I divide this? I'm going to go kind of quick. I would need an x squared, which gives me an x cubed plus a 1x squared. And I go through and I change the signs. So this is going to become minus and minus. So that's how I get a 4x squared and then bring down the minus 17x. That means I need a 4x. Get me 4x squared plus 4x. But then I change the signs, minus and minus. So that's how I get a negative 21x and bring down the minus 21. So I need a negative 21, get me negative 21x minus 21. Gets me plus, gets me remainder 0. So go find your mistake if you made a mistake. Now, I know my remainder should be 0. Why? There's a reason. Why should the remainder be 0?
Wait, how did you get rid of this 21?
Right here, when I change the sign, negative 17 minus 4 makes negative 21. Did you remember
Oh, I
the
just
sign?
remembered the negative in the
Yeah. Okay, the remainder should be 0 because I told you x plus 1 was a factor, right? What does it mean for something to be a factor? If I say, ask you, hey, is the number 3 a factor of 12? You would say, yes, because why? Because if I divide it, it goes in evenly, which means no remainder, okay? To be a factor, it means it divides evenly with no remainder. So if this is a factor, if x plus 1 is a factor, it should have remainder 0. Does that make sense? Okay, so I create this cool factor tree over here. Are you with me? X plus 1, when I divided this polynomial by x plus 1, what did I get? What was the answer? X squared plus 4x minus 21. Right? So that means if I take these two and multiply them together, it would give me that original polynomial. Yes? Okay, back to my basic numbers. Are you with me? You got your calculator still handy? Okay, in my example, if I gave you 17 was one of the factors, you found this one by doing division. And then if I said I wanted that number factored, are you done? Is this done?
No.
No. What would you do next?
Factor the polynomial that you created.
Say that again.
Didn't you just factor the polynomial that you created?
And that's my point here in just a second. Yep. What would we do? We would take 171 and we would break it down more, right? And we would keep going until what? Till we got all the factors. How do you know when you're done? What is it you're looking for when you're done?
Prime numbers.
You're looking for prime numbers, right? You know you are done when it's prime numbers. Do you understand how to know when a polynomial is done being factored? It's considered a prime factor if it's an x to the first. An x to the first will not break down anymore, okay? An x squared, he'll break down. An x cubed will break down. X to the fourth, I can do this forever, right? But an x to the first does not go any smaller. So when you get to x to the first, he's done. This one has an x squared. Can he break down more? Yes, he can. Now, how do you factor an x squared plus 4x minus 21? This is a basic quadratic. You know how to factor basic quadratics. Do you remember this? Where you go through the factoring method. And we say, okay, what multiplies to negative 21? So I need two numbers that multiply to negative 21. And do what? Add to 4. This is factor by grouping here. Once we get to an x squared, we can factor by grouping. Does that make sense? So factor by grouping doesn't work on the x cubed. It will work on the x squared. Okay? All right, so what two numbers multiply negative 21, add to 4? Who's got it?
7, negative 3.
Nice. 7 and negative 3 are my numbers. Then you ask yourself, can I use the shortcut?
Yes.
Because what? Because a is 1. Because of that 1x squared, I can go straight into my shortcut, my answers, which are what? X plus 7 and x minus 3. Now, are these two prime or do they go any further? They're done because they're an x to the first. They're prime, right? Just make sure you understand that. Okay, so right down here it says rewrite our function in factored form. Do you see that? So how do I write this in factored form? What were my factors? X plus 1 and x plus 7 and x minus 3. You took a cubic and you were able to factor it. using division and then factor by grouping. Yeah? Hey, this is a review. What are the zeros of this function? If these are the factors, what are the zeros? -1, -7, and 3. Remember, that's what I would plug in for x that would turn these into 0. If I plug in -1, yep, that makes that 0, and that one. Yes? Okay, turn the page. Guess what? You can do this again. Make sure you got it solid. Okay, beginning of 10.2, we do that exact same thing. Practice makes perfect. Find the zeros of this function given x minus 4 is a factor. So if I give you one of the factors, what do you need to do? You need to what? Divide it. Here we go. We're going to divide x minus 4 into x cubed plus 6x squared minus 15x minus 100. Okay, go divide it. You get another round of practice. Go. All right, I think most of you guys are done. I have the answer up here, so if you didn't quite get done or if you made a mistake, take a look up here. You should have got x squared plus 10x plus 25. What does that mean for me? I just love the factor tree, you guys. It means I took that original polynomial and it broke down into what? What did I divide by? I divided by x minus 4, and what did I get? X squared plus 10x plus 25. That's what I broke this polynomial down into those two. Then I asked myself, can I break it down even more? Yes, because this side has an x squared. But this is for to factor by grouping. How do I start that? I do a times c, what multiplies to 25 and adds to?
5 and 5.
Good, and adds to 10 is 5 and 5. Then you ask yourself, can I use the shortcut? Yes, therefore my factors are x plus 5 and x plus 5. Do those break down anymore? No. Okay, so when it says rewrite in factor form, what are my factors? They are x minus 4, x plus 5, and x plus 5. If you write that as x plus 5 squared, I think that's awesome. You may choose either way, okay? What are the zeros of this function? Okay, where are the zeros? What would make this 0? Positive 4, what would make these 0? And negative 5. You feel good about that? Okay, moving on. Right here, we are not going to do example 1. I'm just going to talk to you about it for just a minute. Are you ready? This question says, is x squared minus 1 a factor? It doesn't say it is. They want you to figure it out. Is it a factor? Let's go back. How do you know if something is a factor? If it has a remainder. So what would I have to do? You're not going to actually do it, but what would I do if you had to do this problem? You would actually divide this, right? You would do long division, and when you were done, you would take a look at the remainder. If I have a remainder, then the answer would be no, not a factor. If there's remainder 0, then the answer would be yes, it's a factor. Make sense? Okay, turn the page. You guys are going to love this page. Are you ready? And I'm not being sarcastic. You really will love this. Take a look. There is a quicker way to divide polynomials. Long division is just that. It's long. I got a fast shortcut for you. Are you ready? It is called synthetic division. Now, some of you are going, are you telling me there's a faster way and you made us do the long way?
Yes.
The answer is yes, and there's a reason, okay? Synthetic division is awesome, but only is good for certain division problems. Unfortunately, we don't use it on every problem, okay? We use it when you have a linear divisor with a leading coefficient of the divisor is 1. Now, we're going to talk about what that means. Okay, so synthetic division we're going to use when it has a linear divisor. Okay, the word linear makes you think of a straight line, right? Okay, let's talk about the equations of a straight line. Would a straight line ever start with an x squared? No, because what shape do x squared equations make? Parabolas, right? Would ever start with an x cubed or an x to the 4th or any of that. Linear equations start with what? An x to the 1st, right? So a linear divisor has to have x to the 1st and not any higher, right? What is a coefficient? Do you know what a coefficient is? It's the number in front of the variable. So not only does it have to be an x to the first, but what does the number in front of it have to be? A 1. So the divisor has to start with a 1x to the first. Does that make sense? So we're going to do these problems, but let's talk about these for just a minute. For example, here are 4 division problems. Could I use my new fast method, the synthetic division, on this first problem right here?
No.
Because what?
It's two.
Because it's being divided. This is the divisor, and I said it has to start with a 1x, right? So this 2x cannot be used. You would not use synthetic division for this one. Could I use it for the second one?
Yes.
Yes, because the divisor starts with a 1x. Could I use on this one? No, because the square. Could I use on this one? Yes. Okay, so that's what it means. That's when we use synthetic division as a linear divisor with coefficient 1. Okay, skip this for just a minute. Or actually don't. Never mind. Let's go ahead and do it. It's just helping us recognize the difference between a factor and a 0. X minus 5 is a factor. Okay, when you find factors, x minus 5 would be a factor. If x minus 5 is a factor, what would its 0 be?
5.
Just positive 5, right? Okay, if x plus 8 is a factor, then what's the 0? Negative 8. If x minus 2 is a factor, then 2. This is important because in synthetic division, the 0 goes in the box. So, if the factor is x plus 2, then I put negative 2 in the box. Probably the biggest mistake that students make using synthetic division is they put the wrong sign here. They see x plus 2 and they want to put what? Positive 2. But we put the 0 in there, therefore we put negative 2. One student said, does that mean you just change the sign? Ultimately, yes, right? But don't forget that. The reason being is this is the factor, this is the 0. Okay, here's how synthetic division works. You put the 0 here, and straight across go the coefficients, these numbers right here. So if I'm dividing this by x plus 2, the 5, 7, negative 8, negative 10 is what goes in the first row. So far, so good? Okay, we fill in the rest of the numbers as we go. So you would start by just having this much. And then to begin, the first number, he always drops straight down. So the 5 comes straight down. Then get in your head from there, multiply, add, multiply, add, multiply, add. That's what it's going to do. I take this 5, I multiply it by the number in the box, which gets me what? Negative 10. And then I take these two numbers and do what? Add. And that gives me negative 3. Then I repeat. Multiply, negative 3 times negative 2 is positive 6, and then I add, getting negative 2. Then I multiply, which gives me positive 4, and then I add, getting me negative 6. Make sense?
Not be a factor though, because it has a remainder.
It would not be a factor, but this is just a plain division problem, just divide it. But you're right, it would not be a factor. Yes, good point. Okay, now, when we use synthetic division, notice there are no variables. They took all the variables out. For the answer, you have to put the variables back in, okay? So here's the remainder. I personally always like to box off my remainder, just to remind myself, hey, here's the remainder. And then you do place values. You know how, like, normal numbers, ones, tens, hundreds, thousands, same idea. Where the place values in polynomials. You have your remainder, and then you have your constant. He's the x to the 0. Then what? Your x to the first, and then what? Your x to the second. So you have to go back in and put in your variables, and then your connectors. He's a negative, so that would be minus. He's a negative, so that would be minus. So my final answer would be what? 5x cubed minus 3x minus 2 plus the remainder over the divisor x plus 2. Make sense? Okay, let's try it. Here we go. It says this is the same problem we started with. When we did long division, we're going to do synthetic division now. So start with your box. What number goes in the box if x minus 4 is the factor? Thank you. Positive 4. You put the 0 in. If x minus 4 is the factor, I need the 0, which is positive 4. Then I do the coefficients, the numbers here in front of all the variables plus the constant, and I have 1, 6, negative 15, and negative 100. Leave yourself a little bit of space and draw a line. So far, so good? Okay, first number, he drops straight down. If you need to put an arrow to remind yourself, you can. That's optional. He drops straight down. And then repeat, multiply, add. Multiply, add. Okay? So from here, I multiply to the number in the box, which is 4. Then I add, which is 10. And then I multiply 10 times 4, 40. Then I add. Who knows negative 15 plus 40? Nice. And then I take this and I multiply. Who knows 25 times 4? And then I add. Okay, now that just gives me the numbers. How do I write the answer? He is the remainder. This is my constant, or my x to the 0, x to the first, x to the second. But then I need connectors. So when I divide it, I get x squared plus 10x plus 25, right? Does that answer sound familiar to you? Take a look. This is the same problem that we did at the very, very beginning. If you flip back a page, that's the same problem we did at the beginning. Do you see that? X cubed plus 6x squared plus minus 15x minus 100. That's what I have right here, divided by x minus 4. Do you see that? Okay, everybody, eyes up here once you see this. Here's why synthetic division works. Are you ready? This is the same problem in synthetic division and long division. Take a look at these numbers. Do you see the 6, 4, 10? Come over here. 6, 4, 10. Do you see negative 15, 40, 25? Now come look over here. And do you see the negative 100, 100, 0? Right there. Synthetic division is long division, just simplified. By removing all those variables, however, it just only happens to work when you have a linear divisor with coefficient 1. Does that make sense? But otherwise, it's awesome. Okay, I'm going to rush through this next part, so pay close attention rather than writing. Okay, the original problem said find the factored form. So recognize what was the first factor I used. What did they give me? X minus 4. Then what would I do with this? I would take the x squared plus 10x and do what? Plus 25. And break it down by doing the factor by grouping, right? What multiplies 25, adds to 10. This is the same problem from the front page. What did we find? We got 5 and 5, so we got x plus 5 and x plus 5. It's the same problem, right? So the same answer here. Do you understand that even though you do synthetic division, you still get to the same quadratic, and then you just factor it just like you did before. Okay? Therefore, my zeros would be 4 and negative 5. Same answers I got on the front page. Okay, turn the page. Remember that problem that we skipped? But we just talked about it. Is this a factor? Okay, could I do synthetic division to do that?
No.
No, because why? Has an x squared, right? So you would have to do long division. We're not going to do it. I know you could if you had to. But since you can't do synthetic division, it gave us another problem to try. We want to do one more synthetic division. Make sure you have this down. Okay, this question says, notice I'm not finding the zero. It says, is it a factor? I'm going to know if it's a factor if the remainder is 0, right? Okay, can I do synthetic division?
Yes.
Yes, what number goes in the box?
Negative 3.
-3. Why? Because if x plus 3 is the factor, I put the 0 of -3 there. Okay, if you worked ahead and you have the numbers 3, -20, 19, and 5 on there, you are wrong. What did you miss? Who can catch it? You gotta have a 0. Remember, every place value has to have a spot. If this starts out with x to the 4th, then my first number has to be x to the 4th. What does my next number have to be? The x to the 3rd. And if x to the 3rd is missing, I gotta have a 0. So we're gonna have 3 for the x to the 4th, but I have to have a 0 for the x to the 3rd. Then the -20 for the x squared. Then the 19 for the x, and then the 5 for the constant. Okay, if you do it on your own, I think that's awesome. Otherwise, I'm going to do it step by step if you want to do it with me. First number drops straight down. There's 3. And then I multiply, add. Multiply, add. So here we go. 3 times -3. I always multiply times the number in the box. Is -9. And then I add. If you are not awesome at adding positive and negative numbers, grab a calculator. Okay? You are By the way, you are responsible for bringing your own calculator to class, and I give a 5% bonus on tests if you have a calculator on test day. You bring your own. I don't care if you borrow it from a friend or whoever, but if you bring your own on test day, that bumps your whole grade 5%. Okay, then I multiply negative 3 times negative 9, positive 27. Then I add. Then I multiply. Then I add. Then I multiply. And then I add. Okay, just for practice, I know this isn't the answer, but practice putting your variables back in there. Just for practice. What would the answer be if you were just dividing? This would be my remainder. This would be my constant. Then my x. Then my x squared. Then my x cubed. Make sure they all have a connector, meaning he would need a plus. And if I was writing that remainder, say it was just a basic division problem, I would put the remainder over what? Which was x plus 3. Just a quick reminder. Okay, what did the question actually ask? Is this a factor? Yes or no? No, because why? There's a remainder. Okay, your homework is half and half, you guys. Half paper, half big ideas. Turn the page. There are 3 problems here that you are to do. Problem number 1, find all the zeros, but it gives you one to factor to start with. Can you do synthetic division on number 1?
Yes.
Yes. Problem number 2, can you do synthetic division? What does it give me? This one, it tells me what? One of the zeros is 4. What does that mean? It means x minus 4 is a factor, right? 4 is the one that goes in the box. It gave me a 0. Okay, problem number 3, it says, is 2x minus 3 a factor? Can I do synthetic division? No. What's going to be required on number 3? Long division. Okay, then when you turn the page, this is where you do the big ideas. I'll be honest, these 3 problems are going to take way longer than the big ideas. Okay, these 3 are going to take you a little while. The big ideas is straight synthetic. It just gets you practicing that synthetic division. They should be fairly quick. You have the rest of class time, which is a good 20 minutes to work on this assignment. If you did not finish 10.1, the long division, or even start it, you may choose where you want to start. I'm here to help you on any problem you want help with.